Now we see how we can convert Mealy machine to the Mealy machine. Means we need to convert the Mealy machine to the equivalent Mealy machine. So we have the theorem which says that for every Mealy machine, ME, there is a Mealy machine M0 equivalent to it. So this means from every Mealy machine we can obtain the Mealy machine. So how we can obtain? We can consider the state by state. So if we have the situation like this, so how we can convert? So see, we are going to convert the Mealy machine. So in Mealy machine we will have the state like this. So during the transition it is going to produce the output. So if we have the some state Q, and see that in this state Q we have some incoming edges and some outgoing edges, and also you can see that the incoming edges have different output. Like here you have the B. Once you are coming to this B, then you are going to print 0. If you are coming through this edge, you are also producing the 0. But once you are coming through this way, means, and this for this input B, it is, we are going to print 1. So this means, and we have the outgoing edges. Okay. So what we need actually, we need to consider only the incoming edges, and see, since the incoming edges has different output, so we are converting to the Mealy machine. So Mealy machine is going to produce the output at the state once we are going to enter to the state. So we have to give the output for this state. So here we have the situation that different edges are incoming to this queue, and they have different output. So what we need to do, we have, say for example, we have here two output, one is 0 and one is 1. So for every output actually we need to copy the state queue, so that for every output we can produce the output during the entry of the state. So how we can do this? So actually we need to go for the copy of this state. So we can, from this we can say that we will have the copy now. So see, we have the state queue. This is the state queue. Now we say that this is 1, and what is the output? We can say 0. One output is 0. So this is one copy, and other output is what? 1. So we have the state Q, and this is the second copy, and we can say what is the, here output is 0 and here output is 1. This is the, so we have the two copies of this state Q. Now the edges which are incoming to the queue and they are producing the 0, they are printing the 0, should come to the this. So what are the edges? The edges coming for the B. So now here we will have simply the level of the input. So for the B, you are coming to the state Q and you are going to produce the output 0. For the A, you are coming to the state Q and you are going to produce the output 0. Now here B, we have the B, and B is going to produce during the transition for the input B, the 1 is printed. So we can say that in the second copy the edge B is coming, and you can do like this, and outgoing edge will remain same. So what, from Q we have the two outgoing edge. One is, we have A/1 and other is B/1. So here also we will have the same outgoing edges. So you will have the A slash 1, and we have the B slash 1. So see what we have done. We have we have we have the copied this state Q, as we have the two output 0 and 1. So we have the two copies, and for the case of the output 0, whatever the incoming edges have the printing the output 0, they are coming to this state, and in the whatever edges are printing the 1, they are coming to the second copy Q slash 1, and whatever be the outgoing edges are there, they remain the same. So this state we can obtain this kind of equivalent form. So this state becomes like this. Next possibility is like this. In some state is having this, some state have the loop. So one is coming for the output and printing the output 0, and here we have the loop for the B, and it prints the output 1, and there is one outgoing edge from the state P which goes to the Q, and the transition is less 0. So how we can convert this? So see what we need to do. We need to again make the two copies for this, because we know that the two edges level have different outputs. So we can make the two copies. So one is, say for example, one is P1, this is first copy, and this is for output 0, we can say. And other we can say we have the P2, and this is for the output 1. So we have the two copies of the state P, two copies. Now the incoming edge of P is 1, which produces the output 0. So we can say that, okay, yes, it comes, and this is coming for the A, and once it is going to enter to the state P, it is going to produce the output 0. This is, and we have the state Q, we have the state Q here. Okay, we have the state Q here, and the one edge is going to the, one is the outgoing edge which goes from P to Q. So we can have P to Q, and the label is H less 0. Okay, so this is now in case of the second copy, the output is 1. So this is for the loop. So for what your output is, for the case of the B, you are going to produce the output 1. So B will have the edge from here to here, from first copy to the second copy, and this is for what? This is for B. So for the B, you are coming to this, and you are going to produce the output 1, and if you are in the second copy, P2 slash 1, P2 in the second copy P2, so we can make the loop here and for the B. And from this copy also, we have one outgoing edge which goes to the Q. So from here also, we can make an edge which goes to the Q, and the label of this edge is A slash 0. Now, this state P is converted to the form of the Muri. Now we have the remaining edges. You know that this edge is not satisfying the Muri, this is also not satisfying the Muri, and this is also not going to satisfy the Muri machine. So but we, for the time being, you can leave this, we can leave this, because one by one you are going to convert into the form of the Muri machine. So this is the algorithm. So algorithm says that you can convert one state by state to the equivalent form of the Muri machine from the given Mealy machine. So let us see one example. We are given the Mealy machine. This is the Mealy machine, and we want to obtain the equivalent Murray machine. So from Mealy machine to Murray machine. So how we can convert? So we can start from the initial state Q0 one by one. So every state we are going to convert into the form of the Murray machine. So we have to consider the state by state. So we can start from the Q0. So see, if we start from the Q0, then what happens? We can start from the Q0, and we can see that in the Q0 we have the incoming edge A, which is producing the output 0, and incoming edge from the Q3, which is B, and printing the output 1. So what we need to make the copy of this state. So Q0 we have to copy now. So we can say we have the Q0, and this is the first copy, and this is for the output 0. So this is the state. This is one copy, other copy is Q0, and this is the second copy, and this is for the output 1. This state is going to produce the output 1. Now Q0 is the initial state, so arbitrarily you can make any one of these state as the initial state. We can make this as the initial state. So you can make this as the initial state or this as, there is no problem. So what we have made the copies of this state. Now the edges which are incoming to the Q0 and which are producing the output 0 will be here. So from where you are coming? From the Q1 actually. From the Q1 we have the edge which is coming to the Q0, and it is going to produce the output 0. This edge is entering to this state Q0, so it is going to produce the output 0. So we just label with the input. So you can say A. So all other states will remain. Here you have the Q1, and Q1 say we have the same, whatever we have the same here. Now you are at the Q2 is here. You can say this is the Q2. The state is Q2, and we have the loop here for the B0, B/0, and then from Q2 you are coming to the Q1. Everything is same. So you are coming to the Q1, and for the label is A/1. Now you have the Q3 here. We have the Q3, and from Q3 we go to the state Q2, and the label is A/0. So in the Q01/0, so the edge is coming from the Q1, and for the A it is going to produce the output 0, and the outgoing edge from this is what? One outgoing edge goes to the state Q2. So we have the same outgoing edge. So we can have and this is the label is A/1. A/1. Now other outgoing edge goes to the state Q3. So from here, and what is the label of this? This is for B/0. So we have the two outgoing edge only. So we can mend. Now one edge is going from Q3 to Q0, and for the B, and output is 1. So we can join this incoming edge. So we will have from Q3 to Q02 we have the edge, and which is label of this is what? So what we have done, we have we have the state Q0, and since we have the different incoming edges with different output, so we have made the copies. So we have made the copies, and we have two copies now for the state q0. One is going to produce 0 and other copy is going to produce 1. So from q1 we have the age to the q0 first copy for the A, and from the q3 we have the age goes to the q02 for the B, and outgoing age from the second copy should also go to the state q2. So from q20 we have the outgoing age goes to the q2, and what is this? This is for the A/1. Now other outgoing age goes to the state q3. So from q02 in second copy you should also go to this place, and for the label of this is what? The label is B/0. Now we have done. So we have considered just initial state, and we obtained this resulting form. This is the result. Okay, so for the initial state we have made two copies. Now this is the resultant. Now we need to, like this, we have to consider the states one by one. Now from this actually you see that we have now q1 and q2 and q3. If you go for the q1, then we have seen that the one is the loop which produces the output 1, and other incoming age is coming from the q2. This is the q2 state. This is the q2. From q2 we have the age to which goes to the q1, means q1 has incoming age, and this incoming age is also going to print the 1. Output is 1. So what we can do, we can replace this q1 with q1/1, means this state is now going to produce the output 1, and the B/1 is relabeled as the B, and this the age from q2 to q1 should be relabeled as A. Now this is converted. Similarly for the q3, actually two ages are coming from the two copies of the initial state q0, and they are producing the output 0. So only these two incoming ages are there and output is same. So just we have also replaced this q3 with q3/0, means now q3 is going to produce the output 0, and we have relabeled the ages as the B from the first copy of the q0 coming to the q3 and labeled as B, from the second copy of the q0 coming to the state q3 is labeled B. So now we have obtained this form. So we have considered the states. Initial state we have considered, then q1 and q3. Now the one state remaining which is we need to consider is q2. So we have to consider the q2 now, and then we will have the equivalent Mealy machine. So now we just need to consider the state q2 only. So see that we have the loop here. At the q2 we have the loop here, and the ages are coming to the q2 is producing the output 1 and 1, and some age is producing the output 0. So 1, 2 and 3 incoming ages are there. So 2 incoming age producing the output 1, 1 incoming age producing the output 0. So we can make the two copies for the state q2. So we have now two copies. One is for the 0 and other is for the 1. So what incoming ages are there? Incoming ages, some incoming ages are for the 1 and some is for the 0. So we have the states. Actually we just draw the states here. At the state q1 we have the loop, and you can maintain the loop, and this is for the B. From Q1 you are coming to the Q0, and this is the for A. The Q0 you are coming to the Q3, this is for the B, and from Q0 second copy of the Q0 state you are coming to the Q3, and this is also for the B. From Q3 you are coming to the second copy of the Q0, and this is for the B. Now from the state Q3 you are going to the state Q2 for the 0. So where is 0? So you can say you can just go from here to here. This is for the case of 0, and it is going to produce the output 0, and label is what? Label is A. You have the label A. This is the label. Okay, this is the only incoming edge which produces the output 0. So this you can join with this copy of the state. Other incoming edges produces the output 1. So 1 is coming from the first copy of Q0. So for the 1 you are going to this state, and this is for the A. Now from the second copy also you are going to the state Q2 for the 1. So this is also for the case of A. Okay, so for output 1, though there are 2 incoming edges, so you are joining to the second copy of Q2 which produces the 1. Okay, and we have only 1 incoming edges for the 0, so you have producers. Now outgoing edge is what? From the Q2 we have the outgoing edge which goes to the Q1. So this is going to the state Q1, and for the input A, this is just 1 outgoing edge, 3 incoming edge and 1 outgoing edge. Okay, so from the second copy also you have to go to this state. So this is from the second copy also, and from second copy also you are going to the state Q1 for the label A. Okay. Now we have the loop at the Q2, so you are coming for the loop is producing the output 0. So from Q2 you should go to the state Q0. From Q2 second copy you should go to the state first copy of this Q2 state which produces the output 0, and this is for the B. And at the first copy of the Q2 state Q12 we have a loop for the B. Okay, so these 2 copies joined because there is a loop, so we can join the 2 copies of the state Q2. Now we have done everything. We have joined all the outgoing edges, and we have properly maintained the incoming edges for their outputs. Okay. And every state we have now considered, and all states, and this actually this resulting machine is actually the Mealy machine. This is the Mealy machine. So we have converted the given Mealy machine into the Mealy machine. So this is the conversion process. So once we convert the Mealy machine into the Mealy machine, so we need to consider the states of the Mealy machine one by one, and one by one actually we are going to convert the states of the Mealy machine into the form of the Mealy machine. When all states we have covered, then the algorithm will stop. So this is the way we can convert any given Mealy machine into the Mealy machine. One thing we can notice here that when we start up the Mealy machine initially, we print some symbol specified by the initial state. That does not correspond to any output from Mealy machine, because Mealy machine never prints any output before reading the input. So here, but this kind of discrepancy we allow in the definition of the equivalent machine. So here we see that this is the start state. We have obtained the Mealy machine, and this for this Mealy machine, this is the start state, and the output produced by this start state is 1. So without reading the input, this Mealy machine is going to produce this output, and the rest of the output string is corresponds to the given input, and this output from here to here, this output is same as the output produced by the given Mealy machine. So we can say that yes, if you ignore the first symbol of this output Mealy machine, then we have the same output string as we have in case of the Mealy machine. Getting the equivalent machine, we can ignore this discrepancy.